All right, hey there guys, it's Miss Campbell, and today we're going to go through radian measure. So we are going to talk about another kind of way to measure angles, and that is with a measurement called radians. So a radian is the measure of a central angle that intercepts an arc with length equal to the radius of the circle. So the radius and this arc length here, those have to be the same distance, and then whatever angle is formed by that, that is 1 radian. Okay, so that's kind of like what a radian is. Now, we're going to be able to convert between degrees and radians, but we're going to get to that part in a minute. Another thing that you can do when they give you an angle in radians, okay, is you're going to be able to calculate the arc length, or if they give you the arc length and the radius, you can find the angle that's created by that arc in radians. So that's what we're going to do here. So first thing, it says the measure of a central angle in radians is equivalent to the arc length of the intercepted arc divided by the radius. So theta, that's your angle in radians, okay? And this is very important. Angle in radians, and that's your central angle. So we'll say central. Your central angle in radians is equal to the arc length, S, divided by R, the radius. And then you can also work the formula the other way around. So let's say you need to find the arc length S, and they give you the radius and then that central angle. You just multiply the radius and the central angle, and that gives you the arc length. Okay, so let's go ahead. We're going to do our first example. So it says, find the length of the arc given the measure of the central angle and the radius. Okay, so we're finding the length of the arc. So we're looking for S, okay, and they've given us the central angle and the radius. So S is equal to the radius times, and then this symbol there, the O with the line through it, is theta. So we're going to do, here our radius is 4, okay, so S, or in this case, I'm sorry, the arc is titled A. So A, the length of arc A is going to be 4 times, and then we have 7 pi over 8. All right, now how your answer is going to look is going to depend upon how they have it phrased in the assignment. If they want you to keep it like in terms of radians, you keep the pi in here, you don't multiply it in. If they want you to round it to the nearest tenth, then you can just multiply this thing in the calculator. So what's going on here? We're going to do 4 times 7 times pi, and then that's going to be divided by 8. So that's how you would do it in the calculator. I'm going to work it both ways though. So I'm going to do 4 times 7, which is 28. So we have 28, and then we have pi, and then over 8. And then you have to reduce that, okay? 28 and 8 could both be divided by 4. And so 28 divided by 4 is 7, and 8 divided by 4 is 2. So it's 7 pi over 2. And if you wanted to get this in terms of decimals, so 7 times pi, okay, divide by 2. And you get 10.99, so it's going to be 11. So we're going to say it's about 11. Okay, next example here. Again, we need to find the arc length, so we take the radius and we multiply it by this angle. So arc B is equal to 4 times 5 pi over 4. Okay, just multiply here. 4 times 5, so that's 20 pi over 4. And 20, you can divide it by 4, and so you'll get 5 pi. You could also notice, you see you have the 4 in the top and the 4 in the bottom. Those can cancel out before you even multiply, and you have 5 pi. And if I do 5 pi, just 5 pi, it's going to be 15.7. Okay, so there we go. All right, so that's how to find the arc length when you're given the angle in radians and the radius, okay? This formula only works if you have radians. Okay, now it says find the measure of the central angle given the radius and the arc length. Okay, so go back up here to our formulas. This time we need to find the central angle, which is theta. So we need theta, and that's equal to, you take the arc length and you divide it by the radius. So theta equals arc length divided by the radius. So theta equals, and here we have 8, and then our radius, because our arc length is 8, and our radius is 2. So 8 divided by 2, theta is 4. Okay, next one. We have here the arc length is pi over 3, and then our radius is 5. So we do pi over 3 divided by 5. Now, what you have to do here, you see we have like a fraction on top, and then it's part of a bigger fraction. What's going on here is we have pi over 3 times 1/5. Okay, basically I'm taking the radius and I'm putting it in the denominator of a fraction, and I'm putting 1 over the top of it. Okay, so we have pi over 3 times 1/5, because multiplying by 1/5 is the same as dividing by 5. So now I multiply the tops together, so I get pi, and then 3 times 5, that's 15. So it's pi over 15. Okay. Next thing we have is to convert between radians and degrees. So sometimes they will give you a radian angle and they want to know what it is in degrees, or other times you'll be given a degrees angle and they want to know what that is in radians. Okay, so for a whole circle, if you go all the way around the circle, in radians, that's 2 pi. Okay, so halfway would just be pi, all right? And then with degrees, well, how far is it all the way around a circle in degrees? It's 360 degrees. Half of it is 180 degrees. So you can see here, we've got this proportion. We've got the degrees out of 360 is equal to the radians out of 2 pi. So we're comparing a part out of a whole, part out of a whole. And since both 360 and 2 pi, they can be divided by 2, you really just end up using this proportion, okay? And so rearranging these proportions, we get a couple of formulas. If you want to go from radians to degrees, you take your radians and you multiply it by 180 over pi. If you want to go from degrees to radians, well, you do your degrees times pi over 180. So notice it's very similar. It's just that fraction that we're using, it gets flipped. So now we just go through and we'll do some examples. It says write each measure in radians. Express your answer in terms of pi and as a decimal rounded to the nearest hundredth. Okay, so we're given degrees and we want to go to radians. So I'm going to use this one here. It's degrees times pi over 180. So I'm going to take 45 times pi over 180. Okay, multiply across. So I get 45 pi over 180. And then, y'all, you've got to reduce this. You always have to reduce. If you just give me 45 pi over 180, it's not going to be considered a completely correct answer. You've got to divide. So I'm going to do 180, and I'm going to see how many times 45 would go into that. So I'm doing 180 divided by 45, and I see that's 4 times. So I can reduce this here. I'm going to divide both the top and the bottom by 45. 45 divided by 45 is 1, so I'm just going to have pi. Okay, and then 180 divided by 45 is 4. So 45 degrees is pi over 4 radians. And then we're going to get this in terms of a decimal. So you do pi divided by 4. And then you get 0. And they want us to the hundredth, so it's 0.785. So it's going to be 0.79. So there we go. That's the first one. Okay. Now now we'll do the next one here. It's negative 240 degrees, okay? We're going from degrees to radians. So we do negative 240 times pi over 180, okay? Now, if y'all are using the calculators from the school, it will reduce these fractions for you. So I'm going to do negative 240 divided by 180, okay? Because here, I'm going to multiply this together, so I'm going to get negative 240 pi over 180, okay? And then I'm just going to type in the two number part. I'm going to leave the pi out of it. And so when I do that, when I do negative 240 divided by 180, I get negative 4/3. So it's negative 4 pi over 3, okay? And if you don't have this calculator at home, we have sent out some information where you can download the digital version of our calculator, and you can press the same buttons. It's just like you're in class, but just working the calculator on the computer. So it's negative 4 pi over 3, and so now what I'm going to do is I'm going to do negative 4 times pi and divide by 3. So, and that will give us negative 4 point, and it's 188, so negative 4.19, because we're rounding to the nearest hundredth. Okay, and the negative sign, it just stays on there. And then now we'll do 300. Okay, so again, we do 300 times pi out of 180. So it's 300 pi over 180. And then I'm just going to practice, with simplifying here. I know I'm looking at this as like 30 and 18 because they can both have a 0, so we could divide by 10, right? So I know 30 and 18 are both divisible by 6. And so that means 300 and 180 would be divisible by 60. So 300 divided by 60, that gives me 5, so 5 pi. And then 180 divided by 60 gives me 3. So I have 5 pi over 3. And I look, 5 and 3, I can't reduce that anymore. So that's what that one is. So 5 pi over 3. And then let's just get that as a decimal. So 5 pi divided by 3. We get 5 point, and then it's 235, so 5.24. That's what it would be rounded to the nearest hundredth. Okay, so that's degrees to radians. Now we can go the other way around. We can do radians to degrees. Okay, we can do radians to degrees. So now, look, radians to degrees, we do the radians times 180 over pi. So we're doing the other way around. Because if you notice, radians, they all have pi usually, like mostly in these measurements. So we're trying to cancel that out. So pi over 6 times 180 over pi. Okay, y'all. This is where cross simplification is going to come in handy. Do you see how we have pi's on the corners from each other? They can cancel, and we'll just be left with 1 there. Okay, so now we'll just go across. 1 times 180 is 180. 6 times 1 is 6. And it says we need to round our answer to the nearest degree if necessary. So let's see here, 180 divided by 6, well, that's 30. So pi over 6 radians is 30 degrees. Okay, now we're going to do 7 pi over 4. So we do 7 pi over 4 times 180 over pi. Okay, my pi's on the diagonal cancel out. So I'm just going to do 7 times 180. So 7 times 180. It's going to be 1260. And then over 4, because there's nothing else on the bottom besides the 4. So now 1260 over 4, I can definitely probably divide 1260 by 4. So let's see here. Divide by 4, it's 315. That's 315 degrees. So that's almost a full circle. All right, and then the last part here, we have negative 4 radians. Okay, so negative 4, that's our radian, times 180 over pi. All right, now this negative 4, it's really negative 4 over 1. So just multiply the top, so do 180 times 4, and that would give you 720, and it's negative 720 And then on the bottom, we're just going to have pi. All right, so there we go. That's all there is to it, to converting between radians and degrees. And then also remember on the front, we used our central angles and our arcs and the radius to either find the arc length or to find that central angle. And remember, if they're expressing to you the angle in pi, that's in radians, you're going to use these formulas. And it's a little bit different than the arc length formula for when we learned for degrees. So just make sure you're very careful with that. And if you have any questions, just let us know. We'll see you guys in the next one.